Thank you, everyone, for coming this morning to Remote Decision Support with CDS Hooks. My name is Kevin Shekleton. I am a distinguished engineer at Cerner. I've been there for 16 years. I work on a variety of different things at Cerner, but one of them is on some of our newer interoperability support, such as SMART on FHIR and CDS Hooks. I also work on the CDS Hooks team within HL7 to help define and shape the CDS Hooks specification. So for those of you yesterday that saw Josh and Dan give their great presentation on SMART on FHIR, or any number of presentations on SMART on FHIR, I'm here to tell you there's actually a little bit of a problem with smart apps. So consider this smart application, the bilirubin chart smart app. That is a smart app that's only intended for newborns that are 120 hours in age or less, and that have bilirubin results that either are not documented or outside of their accepted range. So how does the user know that that app is even available to them? So that this app actually exists in their environment. How do they know that it's there? Or the user needs to know that the app is relevant. In this particular case, they need to know in their head all those conditions present themselves so that they would then run the application. And then finally, let's say that the user knows that their organization has this smart app. They know that the condition for the current patient requires the use of the smart app, or that they should use the smart app. Now they need to go where to find that smart app in the EHR or wherever in their workflow. And so that was the initial use case and kind of problem statement that was the reason why CDS Hooks was created. Now, CDS Hooks not only satisfies or addresses that particular use case, but actually is generalized to a broader set of use cases, which I'll talk a bit about. But I just wanted to share with you just kind of the genesis of CDS Hooks. So simply put, CDS Hooks is a vendor-agnostic remote decision support specification. It was created originally by the Smart Health IT team. It is open source, so it's licensed. The specification is licensed under the Creative Commons Attribution 4.0 license. And it is a project within HL7 now, and we just recently wrapped up or are finishing up our first ballot within HL7 with an intended 1.0 publication later this summer. So within CDS Hooks, there is a very core concept, which is a CDS service. And a CDS service is this remote decision support service. So remote meaning it is it's external to the EHR. It can be written by some third party, so another company or some vendor. And this CDS service is invoked by the EHR via something that's called a hook. You can think of a hook as like a trigger or an event within the workflow. The CDS service, upon being invoked by the EHR on this hook, evaluates using its own logic. So it evaluates the rules or whatever decision support mechanism it has using its own logic, its own rules. It doesn't have to express those rules in any shareable or machine-readable format. And it can use FHIR data in the evaluation of that logic. It then returns the decision support, if it has any, back to the EHR in this thing called cards. And I'll get into each one of these things here in detail. So when I said that it's a remote decision support service and that logic can be developed however it sees fit, I really mean that. So it can be developed using just a procedural, rule-based algorithm, a neural network. It can be backed by a mechanical Turk or even a Ouija board, or completely random. It doesn't matter at all with the CDS service. That's not defined at all in the specification. It's totally separate from the concerns of everyone but whoever is implementing the CDS service. They decide however they want to implement that decision support. Now, I mentioned that CDS services are invoked by the EHR via these hooks or triggers or events. And so some example hooks that you can think of. So a hook called patient view, which basically says this hook is invoked when the user opens up a patient's chart. So you're viewing a patient's chart. The EHR would then trigger off, hey, this is a patient view hook. Another one would be medication prescribe, when the user has selected a medication for prescription. And then finally, order review, when the user is viewing pending orders, then we have this order review hook. Now, the CDS hook specification actually doesn't define any hooks. Instead, it defines how you would go about defining a hook. And we leave the definition of hooks to be done outside of the specification, because we imagine that there will be new hooks being created all the time, and all of the hooks that get created are going to be based upon the EHRs and other vendors that are implementing CDS hooks. And so based upon their capabilities within the EHR, within their clinical system, they'll decide which hooks they support. And naturally, we'll have at some point, I can imagine a registry of hooks where various vendors or various individuals are saying, these are, I support the patient view hook, and there'll be standardization around the definition of what those hooks are. But from a specification standpoint, we don't define each of these individual hooks. Instead, we just define how you would go about defining a hook. So let's walk through a workflow with CDS hooks. So imagine a user is in the EHR. They're trying to prescribe this medication here. So they select that medication for prescription. And at this point, the EHR triggers off a medication prescribe hook and calls all of the CDS services that are interested in this particular hook. So again, these are remote services, remote from the EHR, and they're sitting there waiting to get invoked on the hooks that they care about. In this case, medication prescribe. So this EHR invokes those remote decision support services. Those services evaluate their logic and do the decision support, the decision support however they see fit. And they can use EHR data via the FHIR server, so they can reach back into the EHR's FHIR server and leverage additional data if they need to. They also may have their own proprietary data that they use. So maybe a curated set of data that makes their decision support service unique or special. So they can leverage all of that data, and then they return that decision support back in the form of those cards that I mentioned earlier. And these cards are actually, it's actually a machine-readable JSON API. And that API then is rendered and interpreted by the EHR, so it's interpreted in a native fashion. So the decision support comes back as JSON. EHR interprets that and renders that decision support within the workflow. So in the case here, it might be just textual information. So in this case, hey, this drug is going to cost $200 per month, and the patient only pays $30. Or that decision support may be, hey, why don't you switch to this other medication instead? So the EHR interprets that decision support, that JSON, and in this case, not only displays information to the user, but also displays an action or a suggestion to the user for them to switch the medication that the user is trying to place. And then finally, going back to our original use case that was the inception behind CDS hooks, which is, hey, here's a smart app that you should consider running. So it's pushing the smart app to the user. So going back to our bilirubin chart smart application, you can imagine that if you were to open up a baby's chart, the CDS service could go and say, hey, what is the age of the patient? Are they less than 120 hours in age? Do they have bilirubin results charted? If so, are they outside of our normal range? If so, push a card to the user that says you should launch the bilirubin smart app. And here's the reason why. So let's look at that flow from the JSON. So here, the EHR is invoking our CDS service, and it does so by posting to an endpoint. And in the post body, so this is that initial request for a hook. In that post body is a JSON API that has data around the hook, the EHR, and the context that is specific to the hook. So in the patient view hook, the context that is specific to that particular event or hook is what is the user that is logged in that's in context. So that is a reference back to the EHR's FHIR server for in this case, a practitioner. What is the patient ID, and optionally, what is the encounter ID of the current patient's chart that we're opening? And both of those values are also references back to the EHR's FHIR server. So this context information is critical to every request to the CDS service. And this context information is different for every hook, because each hook is a unique event or a unique workflow. and we'll have different values that are required or optional. So in the case of opening a patient's chart, the two required values here are user and patient, and optionally an encounter. For a medication prescribe hook, we actually have the same three values here, but then there's an additional required context field of what is the medication that the user is trying to prescribe. And that, in that case, with that hook, the medication the user is trying to prescribe is expressed as a FHIR resource. So you can see here with the CDS Hooks API that we have a API that is defined explicitly for CDS hooks that's just pure JSON, but we're leveraging FHIR data either via references or FHIR resources as it makes sense. Now, the CDS service, again, remember, evaluates its own logic however it sees fit and returns back that decision support in the form of cards. That cards are just JSON. This is actually an actual valid response here, a complete response for a very simple single card. So you can see that the response that comes back is actually an array of cards. So the decision support service doesn't have to return just one card that ends up getting displayed to the user. It can actually return multiple, or it can return none. Now, I already mentioned that the cards are, you can have multiple cards coming back from a CDS service. Since it's JSON data, the EHR renders that card, which the nice thing about CDS hooks then, which this differs from SMART, where in SMART you have a SMART application that gets embedded, say, within the EHR. Well, that SMART app is going to have a look and feel of its own. Some SMART app developers will try to change the look and feel of their application to make it more look closer to a native EHR experience for whatever EHR vendor they're dealing with. In the case of CDS hooks, since it's all JSON and the EHR is responsible for interpreting and rendering that decision support, the EHR is going to make that look native just like any other decision support that would come from the local EHR system. So every EHR system, or all the ones I'm aware of, have local rules that their clinicians or the organizations can build their own rules and run. So the decision support coming from CDS hooks would be indistinguishable, ideally, from the decision support from the local EHR, which is a great user experience. Every card must have a concise summary, an indicator noting the importance of the card, and details around the source of the decision support. Those are the only three required bits of information in the card. However, there are a bunch of other fields that are optional that can also be included. So again, the most simplest, concise way to represent a card is this right here in the response. So it's very simple, very readable. Obviously, though, there's a lot of other fields that would provide a lot more rich data for the user. That indicator value that I mentioned, there's just three values: informational, warning, and critical. This is an indication to the EHR as to how they should treat and render the card. So you can imagine an EHR might want to color code the cards in some fashion based upon this indicator, or perhaps display them in the EHR in different areas depending on the importance. So maybe an informational card or that decision support that is marked informational may be displayed in a more passive way that the user maybe has to go and click on to discover, as opposed to being something that's critical, which might be more in your face, with maybe an exclamation point or maybe even a modal pop-up. So the EHR gets to decide how that's rendered based upon whatever makes sense for their workflow and their EHR. So some common card examples here, and these examples don't refer to anything in the specification. Like in the specification, there's nothing that says that this is an information card, but when cards have just textual information, we just kind of refer to them colloquially as, well, that's just some information card for the user. But then cards can also have suggestions, which I mentioned earlier. So here we've got both information as well as suggestions. And again, those suggestions are represented as actions with a reference to a FHIR resource, or bundled within the card as a FHIR resource. So in this case, this card here that says switch to this particular medication, that particular suggestion in the JSON actually represents two actions. The first action is to cancel the current order that they're trying to place. So that action would be say cancel, and it had a reference to the FHIR resource that we want to cancel. And then a second action that is bundled with that says I want to add this other FHIR resource here. So the EHR renders that single suggestion with those 2 actions into a single button here that says, switch the order. And then finally, here's our card that returns an app link. So you can return links in cards, and a type of link that you could return is a smart app link. And then so that the EHR knows that this is a smart app and not just some regular absolute URL. Now, you can combine and you can mix and match all this information into a very complex card, like in this case here. So we've got textual information. We've got a single suggestion, and cards actually can have multiple suggestions as well. We've got a link to a smart app. And then something else that I haven't mentioned here is that in that textual information for a card, we actually support in the spec Markdown. So we use specifically GitHub flavored Markdown, which aligns with the flavor of Markdown that FHIR now defines. And so you can do a little bit of styling or indicate a little bit of styling here to the EHR, which is nice. Now, another nice feature that we have in CDS hooks is this notion of discovery. So with discovery, we define basically an endpoint that every CDS service needs to expose, that once you hit that endpoint, it will tell you all the CDS services deployed at that endpoint. So given a base URL, like in this case, example.com, if you call that base URL and you append on there CDS-services, then you get back a JSON document that tells you all the CDS services that hang off of that base URL. Additionally, this discovery endpoint is what prescribes to the EHR the location, the URL location of all the CDS services within that base URL. So what this means is that with the discovery endpoint and with CDS hooks, with just a base URL, you know all the CDS services that exist off of that base URL and how to call each one of them, what hook they're interested in, and so forth. So for instance, if I call the discovery endpoint off of our base URL of example.com, I get back a JSON document that has a list of the CDS services that exist within there. Each CDS service has its own definition that defines the hook that it's interested in being called with, a name, a description, an ID parameter, which basically is used as our URL path parameter for that CDS service, as well as any prefetched data requirements that it needs, which I'll get into in a little bit here. So taking our ID parameter, we can now combine our base URL / CDS services and then the ID parameter. And that URL right there is the URL to the CDS service. So you can imagine a management tool in which you just provide a single base URL, and it can show you all the CDS services that exist under the covers, and the EHR knows how to call each one. So we're very prescriptive as to the URLs for CDS services, which makes it really nice for implementers on both sides here. Now, I've talked a little bit about data access for CDS services, but I want to actually get into a lot more detail because there's many different ways in which a CDS service gets clinical data from the EHR. So there's 3 main methods that they get this data. So the first is through the hook context information. So I mentioned that with like a patient view hook, there's 3 bits of information that are included as part of the context. The user, the ID of the user, the ID of the patient, so those 2 bits are required. And then the final optional one is the ID of the encounter. So you may not open up a patient's chart with an encounter, which is why that's optional. Every hook, again, defines its own contextual data that makes sense for that hook. And so if you were to implement that hook, like the medication prescribed, you'd be required to implement whatever contextual data that hook defines. So that's, you're going to get some information there through that hook context data, which is pushed to you from the EHR. It comes across along with that invocation to the CDS service. Now, the CDS service can also request data be prefetched from the EHR. So this might be, imagine that you've got a CDS service that always needs the full patient FHIR record for the current patient in context. And so you request that this data be provided to you as a prefetched set of data. And the reason why you request this is, the main reason would be that you always need that data. The other reason that you may ask for it is you may be in an environment where you don't have access to call the FHIR server. And so you're basically asking if the EHR could send that data to you. So because you have no way to reach back in, so it's going to push it to you. Now, prefetch is not a requirement, so it's a request of the EHR, and the EHR may not satisfy your prefetch request. So as a CDS service, it would be best if you don't get the prefetch data that you ask for, that you go ahead and then try to request it yourself. Or if you do require it, then you'd have to return some sort of error scenario here. Now, the reason why an EHR may want to implement prefetch is imagine that the EHR is calling, say, 5 different CDS services. And let's say 4 of those CDS services ask for the current patient's FHIR resource to be prefetched. So 4 of the 5 need that data. Well, rather than having 4 of those CDS services call back into the FHIR server and make 4 separate requests for the data, the EHR knows that it's calling 5 different services. 4 of them need the FHIR patient resource prefetched. And so it can get that data just once and then give it to those 4 services that need it. Or the EHR may have this data that is requested to be prefetched already in memory. So let's say a CDS service says, I need this particular lab value prefetched because I need this for my decision support logic. The EHR, and say that the user is already viewing the lab values and they're viewing that particular lab value, the EHR may already have that in memory and may be able to just go ahead and pass that down to the CDS service, and so there's no data call at all. So that's a reason for prefetch. And then the final mechanism is the CDS service could just retrieve FHIR data. So when a CDS service is invoked, it's given access to the FHIR server, and it can call back in during its rule evaluation and just pull data directly from the FHIR server according to its authorization. So I already talked a bit about hook context data. So this is a bit of a refresher, but you can see here that when we define a hook within CDS hooks, you define, amongst other things, what context values, and you define each field, whether or not it's required or optional, the type of the hook context, and then a description for it. It doesn't have to, the hook context values don't have to reference FHIR data, but they certainly should if it makes sense. But you can pass anything within this JSON structure here. The prefetch data is always going to be FHIR data. And again, every CDS service defines its own prefetch data. And also, prefetch, as I mentioned before, is optional. We represent the prefetch data requests as FHIR read and search queries. And I covered all of this already. I apologize for going this. Also, all the slides, I've got a link at the very end with all the slides. So if you want to grab them, you can get them at the end of the presentation. They're all online. So let's talk a bit about security. So CDS hooks has 3 areas of security that we've focused on. So the first is, how does an EHR trust a CDS service provider? So when an EHR is invoking a CDS service, how do they know to trust it? Well, we say that every CDS service must be available at a TLS protected endpoint, so that base URL has to be at an HTTPS endpoint. And via TLS, the EHR will assert the identity of the CDS service by looking at its certificate and all of the normal and standard certificate validation mechanisms that exist as best practices today. The second mechanism, and this is much more involved, is how does the CDS service trust the EHR that's invoking it? So the first step here, the EHR is doing the invocation. So it's in total control over what URLs it invokes. So not only can it use TLS, but it can also have a whitelist of here's only the CDS services I trust. But a CDS service is sitting out there, and it's just accepting requests from these EHRs. And so in order to establish trust of the EHR calling the CDS service, we do so via a signed JSON web token, which I'll talk a bit about here in a second. But it's basically a signed assertion from the EHR that is presented to the CDS service. The CDS service verifies that signature against its list of trusted EHRs, and if it checks out, then it goes ahead and lets the call through. Otherwise, it should return not return its decision support. And then finally, the third mechanism here is I mentioned that the CDS service is able to call back into the EHR's FHIR server. All right, so if you're familiar with SMART on FHIR and that whole workflow, that goes through a very involved workflow around OAuth 2, where the application requests permission to launch, and then it requests some particular scopes or permissions for accessing data in the FHIR server. A user may be involved actually granting, saying yes, I'm going to grant, or the organization may have been pre-granted it. And then the authorization server presents the SMART application with an access token. Well, in the case of CDS hooks, the access token actually comes along in the request to the CDS service, which is very unique. Now that access token is the same, very similar access token, the one provided Smart Apps. The difference is that authorization and all those steps has been done prior to the CDS service getting invoked. So it's not going through an OAuth 2 workflow, but the CDS service is still getting an OAuth access token that is good for the FHIR server. But there's some constraints around that access token that are unique to, as compared to a Smart application. So looking at that JSON web token, or JOT, if you've never seen one before, it's just a long string of characters, which is up here, and you can take this JOT, this string, and you can actually decode it, and you can break it down into the 3 parts. And one of the parts is a payload inside. And inside of the JOT is basically just a JSON object. And in CDS hooks, we've defined the values of what that JSON object is. And we have these parameters in here. So the information that you get in that JOT is, and of course, you would only want to look at the payload of the JOT once you've verified the signature. So if you verify the signature on the JOT, and so you assert that, yes, this came from a trusted EHR, then you look inside at the payload, and the payload tells you who issued the JOT. So you want to compare this to your whitelist of known EHRs that you trust. We pass in there the CDS service being invoked. So this helps against an attacker from potentially taking a valid signed JOT that was given to some CDS service A over here that maybe was compromised, and taking that JOT and then giving it to CDS service B over here and trying to get it to verify or get it to use and accept that JOT. So we say in the JOT, this is the URL that we're calling. So if you get a JOT and it has a URL that's not one that is for your domain, you would then reject that JOT. We just added in, as part of the ballot process, which is very exciting, a new tenant identifier. This identifier identifies the healthcare organization or entity or tenant that the EHR is operating under. And so, for instance, if you write a CDS service and you have hospital A over here that is paid for your CDS service, but hospital B has not, and both of those hospitals are, say, Cerner hospitals, this identifier tells you which particular entity or organization or tenant that is, so you can only respond accordingly to whatever organization is authorized to use your CDS service. JOTs have an expiry time and a time at which it was issued. This helps to prevent against man-in-the-middle attacks, where a man-in-the-middle were to grab that token, do something with it, and try to give it to you later. And then finally, there's a nonce value here that protects against replay attacks. So once you process a JOT, you should mark it as processed and mark that nonce value as processed within this expiry period here, and that helps prevent against those replay attacks. We have a fantastic sandbox in CDS Hooks. So if you go to sandbox.cds-hooks.org, that has a fully functioning, working sandbox. It's a JavaScript application that runs purely in your browser. So once you've loaded up that page, you don't need a network connection if you're calling CDS services on your local network. We have some, this sandbox kind of operates as like a mock EHR. So when you first visit the sandbox, you will be viewing a patient's chart, and there are some sample or example services that are already hooked and invoked in there, so that as soon as you hit that page, it will call out to those services. The other awesome thing about this sandbox is that you can add your own CDS services, whether running on localhost or you have them deployed. As long as your browser can hit that CDS service, you can call them here within the sandbox. And when you configure them here in the browser, it actually saves it in your browser session so that when you come back, it's all set up again. Additionally, you can change the FHIR server that the Sandbox is hitting. By default, this hits an HSPC FHIR server, which if you haven't used any of the HSPC Sandbox FHIR servers, you should try them out. They're fantastic. But you can switch it to another vendor's FHIR server. So say the Cerner FHIR server or the Epic FHIR server. As long as they have an open endpoint, you can hook it up, which is pretty cool. This has been probably the best resource within CDS hooks that we've had because it allows developers to play around with CDS hooks without writing any code. And then when you start writing code, you can develop and test everything here within the Sandbox, which is pretty awesome. As a bit of a recap between our separation of concerns, the workflow and hooks, or those triggers, really are the concern of the EHR. So when an EHR vendor supports CDS hooks, the important thing is, well, what hooks are they going to support? Are they going to support patient view, medication prescribe, order review, lab view, et cetera? The actual logic of the decision support is solely owned by the CDS service provider. So those remote decision support services decide what that logic is. There's no one that is writing rules. They don't have to share how those rules are done. It's a black box in terms of the CDS hook specification. That initial context data comes from the EHR, and all additional data other than the prefetch data or calling back into the FHIR server comes from the CDS service provider. And again, a CDS service provider doesn't have to just use FHIR data. They can use their own curated data for their decision support. And the presentation of the decision support is owned by the EHR. Now, this is what I lovingly refer to as my NASCAR slide. So these are the EHR systems that have prototyped CDS hooks at past HL7 connectathons. So this is not a commitment of production level support, though several of these EHR vendors have publicly committed to supporting CDS hooks in production. But these EHR vendors have implemented prototypes at connectathons over the past couple of years. And even more impressively, these are the healthcare organizations and CDS service providers that have been at those same connectathons also participating in CDS hooks. So this list is always growing, and I think this speaks volumes to not only the interest in CDS hooks, but the level of participation that we've received and feedback in our specification from not only EHR vendors and CDS service providers, but healthcare organizations and clinicians, which is pretty awesome. The Argonaut project last year chose CDS hooks as one of their focus projects. And the main use case that we focused on was that initial use case that started CDS hooks, which was returning decision support that had a link to a smart app for the user, which was great. And then also Argonauts funded an external security assessment and threat model for CDS hooks. And we actually ended up using the same security auditor that the Smart on FHIR project used when Argonaut funded that research a couple years before that, which was good. So in 2018, we intend to release our 1.0 specification. So we wrapped up our ballot voting process a couple weeks ago. We have proposed dispositions for the 150 ballot items that we received. We're now going through and applying all the changes. Most of them were just documentation changes. And we aim to get a published specification out late summer. Production pilots with EHR vendors I know are launching this year, which is pretty exciting. So we'll be able to see that for the first time in production with our 1.0 specification. And after 1.0, we don't have concrete plans just yet, but here are some things that we've been talking about. So imagine a CDS service that is used just for women's health or men's health. Pick either of those ones. Well, when you're opening up a patient's chart, say half the time, you'd be invoking a CDS service, and it would be saying, oh, the patient's gender doesn't match what I care about, and I'm not going to return any decision support. So it would be nice if the CDS service could express that somehow, so that the EHR knew to do some pre-filtering. So it didn't call it on every patient's chart open, but only on certain patients, say. Another thing is, how long should an EHR wait before it gets a response back from a CDS service? For And it really depends upon the service. So for some services that are critical, you may wait longer than a service that isn't as critical. So these are questions that we've been discussing that we haven't really addressed in the specification yet. Another one, and this is a pretty big one that's been a hot topic, is event or time-based hooks. So all of the hooks that we've described today have been very user-driven workflow events. So a user does something in the workflow which results in a hook being invoked, or a CDS service being invoked. But what about an event, like just a new lab result comes in? Or maybe nightly, you want this decision support to run. So for these types of CDS services, or these particular types of hooks, the crux of the problem gets down to, well, where does that information go to? Because the user is no longer in context. So with what we've done today with CDS hooks, there's definitely a user in context always. So you know that the decision support, you know who it goes to. Well, with these type of hooks or CDS services, we need to figure out, well, where does that decision support land? And then finally, there are specific use cases that we really want to address. So for instance, the image ordering guidelines or the CDC opioid guidelines. There are some gaps in the specification that don't allow us to support these use cases with our 1.0 specification today. But we know that for 1.1, we want to take a look at that closely. So some of you who are familiar with clinical decision support in FHIR may asking yourselves, what about FHIR's clinical reasoning? Because FHIR does define its own decision support. The good news here is that the folks from the clinical reasoning and from CDS hooks communities are working together. So both of these projects are within the CDS working group within HL7. And really, clinical reasoning is more focused around local decision support and expression of decision support using like CQL. And CDS hooks is focused squarely on remote decision support. There's a bit of overlap there, but it's not a duplicative effort. It's something that we're definitely aligned on. And using CDS hooks, you could write a CDS service that takes a CQL rule, so a machine-readable rule, and execute that rule within your CDS service. So they work very nicely together. So some URLs here are specification and documentation. Today is at cds-hooks.org. When we publish the 1.0 specification, that will live on HL7's website. Our Sandbox is at sandbox.cds-hooks.org. All of our code, the Sandbox, the specification, example projects, all of that is on GitHub. So if you go to cds-hooks on GitHub, you'll find that. And then finally, I've got a tutorial for everyone. This tutorial is open source. It walks you through the process of creating your very own CDS service within the Sandbox. So it walks you through that. You can get that up and running on your local machine. There is nothing to install. It's all JavaScript, all running on your local browser, so it's very easy. Also, this presentation I mentioned, you can grab the slides here. It's also open source, and so please feel free to do that. With that, I've got a couple minutes for questions. Go back, yes. I'll keep it there. I've got a couple minutes for questions. Yes?
How do you avoid alert fatigue with all these bugs?
Yeah, so the question was, how do you avoid alert fatigue with all this stuff? So that's a great question. It's a problem that I know a lot of people are working on and are talked about a lot of times. And it's something that really is not something that we're trying to address with the specification. With our specification, we're trying to address a standard way for an EHR and a decision support service, how they communicate. But we're not saying like how you should incorporate that into the workflow, because a lot of the issues with alert fatigue really break down to how's it implemented in the workflow? Is it configured for the right users and for the right scenarios? So it's not a problem that we're trying to address. Yes?
You mentioned the JOT certificate authorizations. Is that the new modern way, or do you have any comment on the types of certificates we've used over time and what's current?
Yeah, so the question was, I mentioned that we use a JOT or JSON Web Token. Is that like the current practice that we should be using compared to, say, previous security methods that have been used? So I'd say that there's no standard security mechanism that exists. Security is all about risk and threat models. And with the technologies that we're using, JSON Web Tokens are certainly more natural. And so that's why we went down with the path of using a JSON Web Token. But I couldn't comment specifically as to, we'd have to talk about other types of security and other standards that you may be referring to actually compare the two. So, yeah, Brian.
There used to be a workflow, I thought, where a smart app could return a suggestion. Is that gone, or how do you do that? How does the smart app maybe suggest something?
Yeah, so the question was, there used to be a workflow where a smart app could return a suggestion, or is actually called decisions, and is that gone? Yes, that is gone. So we had this mechanism proposed where a user could be pushed a smart app through a card. They could go into the smart app, do something, like make some decisions, and then the smart app, when it was done with that workflow, would communicate back to the EHR, hey, the user's done with this workflow, and here are the decisions they made within the smart app. We pulled that from the 1.0 release because no one had implemented it, or at least we couldn't find anyone that had implemented it really well. So we pulled it from 1.0 just because we didn't want to go out the door with something that didn't have good support. Also, we had concerns with how that decision was communicated, because in the original draft, it was done through a post, or it was done through a URL, redirect. But I think that we'd like to experiment with doing a JavaScript callback, which may be more natural for native EHRs. Yeah, it's definitely something that we want to look at for post 1.0, and it actually fits into that other use cases like the opioid or the image ordering guidelines. So, and with that, it looks like I'm out of time, but I am here for the whole week, and I'm happy to answer any other questions anyone else has. Thanks for coming.